Hi guys, this is Mr. Election. I'm glad to be back here, and this is SS1 class. The last time we talked about the mensuration of plane shapes, whereby we discussed about cube, cuboid, cone, cylinder, pyramid, and prism. But this week we'll be looking at like a continuation of where we stopped the last time, looking at the frustum of a cone and that of a pyramid. The frustum of a cone and that of a pyramid. The frustum is a cut-off region. When you have a cone, if you slice the cone in a parallel way by which you cut it in a horizontal manner that cuts across the base, also in a manner in which it cuts with the base, it's the remnant of a cone produced, and the remainder is called the frustum. If you have a cone, cut it into two, you cut it horizontally, by which you produce another cone out of the bigger cone. The remainder is called the frustum. Before we go into the topic proper, I would like to give you the learning objective of this topic, what we are looking to achieve at the end of the class, which is at the end of the lesson, students should be able to calculate the curved surface area and total surface area of the frustum of a cone. The last time we were discussing about the cone, we talked about the curved surface area, the curved region, how to calculate it, which is pi RL, and we talked about the total surface area of the cone. So number two, we'll be looking at how to calculate the volume of the frustum of the cone. And the last one is how to calculate the frustum of how to calculate the volume of the frustum of a rectangular base pyramid. How to calculate the volume of the frustum of the rectangular base pyramid. So let's go to the top. A frustum, this is by definition, means piece cut off. When a solid, generally a cone or a pyramid, is cut in such a manner that the base of the solid and the plane cutting the solid are parallel to each other. Part of solid which remains between the parallel cutting plane is base, and the base is known as frustum of that solid. Let me take it to the diagram to explain. This is a cone. If you cut a cone in a way that it is parallel to the base, look at the way it is cut here. It produces another cone. So this remainder is called the frustum. It's called the frustum of a cone. If you cut a cone into two, it produces a smaller a cone, but the remainder here is called It's called the frustum. So let us go to the definition again. It means a piece cut off. A piece cut off, which is it takes generally it appears in a cone or a pyramid, in a manner by which the base of the solid and the plane cutting the solid are parallel to each other. You can look at it. Look at the diagram. The way the cone is cut off, it is parallel to the base, producing a top circle and also a base circle, but it is in a parallel manner. So that is the definition of the frustum of a cone. So let us look at the volume of the frustum of a cone. The volume, we all remember that in the last class that the volume of a cone is given as 1/3 pi r square h. 1/3 pi r square h. In order to calculate the volume of the frustum of a cone, let us analyze it with the diagram. This is a whole cone, and the volume is 1/3 pi r square h. Now, if you cut a cone into pieces, and now you have a smaller cone and a frustum. The volume of this cone also here is also 1/3 pi r square h. So if you remove the smaller cone from the bigger one, you have the volume of the frustum, making it that the volume of the frustum of the cone is the subtraction of the volume of the smaller cone from the bigger cone. Is the subtraction of the volume of the smaller cone from the bigger cone. Let's look at the definition. This is the difference between the volume of a cone and the volume of the smaller part of the cone cut off, which forms a smaller cone. And we already know the volume of the cone is 1/3 pi r square h, while the volume of the smaller cone will be given as 1/3 pi r square smaller h. We indicate the height by capital letter H for the whole cone, capital letter H for the whole cone, the height of this cone, and small letter h for the height of the smaller cone. So we have the difference to be V equals to 1/3 pi r square, capital letter R square, to indicate the radius. Capital letter R indicates the radius of the whole cone, the base cone, and the smaller r represents the radius of the smaller cone. So we have V equals to 1/3 pi r, capital letter R square h, minus 1/3 pi r square h. 1/3 pi r square h, where h, capital letter H, stands for the height of the whole cone, and small letter h stands for the height of the smaller cone cut off, while capital letter R is the radius of the whole cone, while small letter r is the radius of the smaller cone. So proceed to the next slide. the curved surface area of a frustum of a cone. The curved surface area of frustum of a what? Of a cone. We all recall that the curved surface area of a cone is given as what? Pi RL. Same analysis. Same analysis. If the curved surface area of this whole cone is pi RL, and this is also a cone, which is also what? Pi RL for the curved surface area. So if you deduct the curved surface area of this smaller cone from the bigger cone, it will give you the what? The curved surface area of the what? Of the frustum. It's like when you have a big bucket of water, then you take half of it. The remainder, if you subtract the total volume of the water in the bucket minus the one taken away, it will give you the what? The volume of the remainder. So if the curved surface area of this cone, if you deduct this smaller cone from it, it will give you the what? The curved surface area of the what? Of the frustum. So the curved surface area of the frustum is given as what? A equals to what? Pi RL1 minus what? L2. Taking L1 as the slant height. We all remember that when we talked about our cone, this is the slant height of the bigger cone, which is represented as what? L1, and the slight height of the what? Smaller cone, which is represented as what? L2. So this is L1, the slant height. This is what? L2. The height is what? From the vertex here down to the bottom is a straight line, but the slant height is what? This. So we look at it again. So the what? Area, curved surface area of the frustum is given as what? A equals to what? Pi R, where capital letter R is what? Radius of the what? Bigger cone, and small letter R is the what? Smaller cone. So in case you are given a question whereby you are given the length of the frustum, this is the equation to use. If you are given the length of the what? The frustum, that is pi L open bracket R plus what? R. From the derivation, if you derive this, go further in what? Breaking it down, you have what? A equals to what? Pi L open bracket capital letter R plus small letter R, where L here is the slant height of the frustum. Where L there, this is the frustum. So this slant height, in the case of a question, you might be given what? The radius of the base and what? The radius of the top. And you are given what? The slant height. You don't need to go to the rigor of what? Solving through the curved surface area of the whole cone. No, you just apply the what? The formula A equals to what? Pi L, where L is the slant height of the what? Of the cone, of the frustum of the cone, and capital letter R is the what? Radius of the larger cone, and small letter R is the radius of the what? Of the smaller cone cut off. I believe we are moving forward together. So the total surface area, we recall in the last class when we were talking about cone, we talked about that the curved surface area of a cone is what? Pi RL. Why the total surface area is what? Pi a curved surface area equals to what? Curved surface area of the whole cone plus the area of the circle of the top plus the area of the what? Of the bottom. The area of the bottom circle plus the area of the what? Top circle. The area of the bottom circle plus the area of the what? Bottom circle plus the curved surface area will give you what? The total surface area. Will give you what? The total surface area. So let's go to the notes. The total surface area of a cone is given as what? The sum of the curved surface area and the area of the top and bottom and base of the what? Of the cone. This is the what? The base. We call the bottom also. The bottom of the cone, the area, which is given as what? This is a circle, it's given as what? Pi R square. So this is also a circle, which is given as what? Pi R square. The only difference is that, you know, we consider the radius to be what? A smaller R and the capital letter R. Capital letter R indicating the what? The radius of the what? Of the larger cone, while small letter R indicating the what? The radius of the what? Of the smaller cone. So since the curved surface area is given as what? Pi L open bracket R plus what? R. That is pi L open bracket capital letter R plus R plus pi R square, that is the area of the top, plus what? Pi R square, the area of the what? The base of the what? The cone. Where capital letter R is the radius of the base of the whole cone, and small letter R is the radius of the top cone, the smaller cone, and L in this equation stands for the what? The slant height of the what? Of the frustum. L stands as the slant height of the what? Frustum. I would like to take the diagram again. This is the what? The slant height. You can follow the cursor. This is the slant height. This is the area of the base. Excuse me. This is the area of the base, while this is the area of the what? Of the top. The total, this is the height of the smaller cone here, and this is the height of the what? Of the what? Of the whole cone, while the measuring from here to down here is the height of the what? Of the frustum. I believe we understand now. I would like to take an example with you. Consider this example. The radii of a circle of the circular ends of a frustum. Radii, that is the plural form of radius. The radii of the circular ends of a frustum of height 6 centimeters. The height of the frustum, that is this h here, The height here indicated h from the diagram. Look at it very well. Is given as what? Is given as what? 6 centimeter. Is given as 6 centimeter. While and they are respectively 14 centimeter and 6 centimeter for the radius. That is the base. The capital letter R here is 14 centimeter and the small letter R here is what? 6 centimeter. The radius are what? 14 centimeter and what? 6 centimeter respectively. That is the base bottom. The base area is the base radius is what? 14 centimeter, while the top radius is what? 6 centimeter. Now we are asked to find what? The curved surface area of the frustum. Find the curved surface area of the frustum. Find the curved surface area of the frustum. From explanation earlier, the curved surface area is given as what? The curved surface area of the larger cone minus the curved surface area of the smaller cone. You find the curved surface area of the whole cone, then you subtract it from the what? Curved surface area of the smaller cone. Or you use A equals to what? Pi L. A equals to pi L, open bracket, capital letter R plus small letter r. I told you in that equation, L is the what? The slant height of the what? Of the frustum. That is from here down here. The slant height of the frustum, and capital letter R is the radius of the what? Of the whole cone, while small letter r is the radius of the what? Of the smaller cone, of the top base of the top of the what? Of the frustum. So let's go to the solution. So this is the solution. We consider the formula given that A equals to what? Pi L, open bracket, capital letter R plus small letter r. I implore you, for better understanding, you can also use the formula pi RL minus pi RL. That is using the capital pi, capital letter R and capital letter L for the area of the what? Whole cone minus the area of the what? Of the smaller cone to give you the what? Curved surface area of the what? Of the frustum. But in this, my solution, I'm considering what? A equals to what? Pi L, open bracket, R plus what? R as the curved surface area. In which what? We know that R is, capital letter R is the what? Radius of the what? Whole cone, and small letter r is the what? Radius of the smaller cone. And L in this equation is what? Is the slant height. So in this equation, before you solve equations like this, we need to calculate for our what? We need to find other parameters. We can find the what? Height. If we find the height, that's how we can find the what? The slant height, because we are only given the what? The radius. We are only giving the what? The radius. We need to find the what? The height of the what? The smaller cone, and the height of the what? Of the whole cone. We have to find the height of the whole cone. But in this case, we are given only the height of the what? Of the frustum, which is what? 6 centimeter. Considering this now, looking at this, this is a right angle triangle. And this is also a what? The whole cone gives a what? Right angle triangle. The whole cone gives a what? Please follow the cursor. The whole cone gives a what? Right angle triangle. While the smaller cone also forms a what? A right angle triangle. From your previous classes, you'll have talked, we've talked about similar shapes. Similar shapes is different from what? Congruent shapes, congruent triangles. This is what? A similar triangle. So we relate the smaller triangle to the what? To the bigger triangle. We relate the smaller triangle to the what? To the bigger triangle. Here we have been given the height to be what? H, which is what? 6 centimeter. The height of the what? Of the frustum is what? 6 centimeter. So what will be the height of the what? Of the what? Whole cone? If I may ask, what will be the height of the what? Whole cone? How do we get the height of the whole cone? Is that we label the height of the smaller cone as what? X. Let's label it as what? X. So the height of the whole cone, that is this capital letter H, will be what? H plus 6. The capital letter H, which is the height of the whole cone, will be given as what? H plus 6. So if you are looking at similar triangles, you relate the what? We have been given radius, so we relate the radius to the radius and the height to the what? To the height. That is the height of the whole cone to the height of the what? Of the smaller cone. We relate the height of the what? Of the whole cone to the height of the what? Of the smaller cone. So let's go to the solution. So this is it. That is h over 6. H over what? H over 6. H is there is the what? Is the height of the what? Of the smaller cone. We take h to represent the what? Height of the smaller cone, and 6 to be the what? Radius of the what? Of the smaller cone. We relate it what? H is the what? Height of the what? Smaller cone, and 6 is the what? Radius of the what? Smaller cone. While h plus 6 represents the what? The height of the whole cone, and 14 represents the what? The height, the radius of the what? Of the what? Of the whole cone. H plus 6 represents the what? The height of the whole cone, and radius 14 represents the what? The radius of the what? Of the whole cone. So we go like we relate it in this way. That is h over 6 equals to h plus 6 over 14. Here we are considering what? Similar triangles. The relationship, how you solve using what? similar triangles. That is, we relate the height to the height and relate to the what, to the radius to the radius. The height of the what smaller cone is h, and the radius of the smaller cone is 6, equals to what, h plus 6, which gives the what, capital letter H, which is the height of the whole cone, over 14, which is the what, radius of the what base cone. If you solve all through and make h your subject of the formula, you give what 4.5 centimeter. I would like you to cross check, solve for h. You cross multiply first and make h your subject of the formula. You get what, 4.5 centimeter. So that gives us the what, the height of the what, of the smaller cone. So the capital letter H, which is the height of the whole cone, if this is what the height here is what, 4.5, and this is what, 6, as given in the question, that is the height of the frustum is 6. So 6 plus 4.5 will give us the whole height of the what, whole cone, which is what, 10.5 centimeter. 10.5 centimeter. I believe you are following. Now, to get the slant height, so we calculate what, the slant height of the what, whole cone, and the slant height of the what, of the smaller cone, to get the slant height of the what, of the frustum. Because if you get the slant height of the whole cone and subtract it from the slant height of the what, smaller cone, it will give you what, this slant height of the what, of the frustum. Consider this. Take a look at the triangle of the diagram. If you have this one to be what, we solve the height of the smaller cone to be what, 4.5, and the radius is given as what, 6 centimeter, and we solve the height of the what, whole cone to be what, 10.5, and the radius is what, given as what, 14 centimeter. Obviously, we can take this small right angle here, triangle here. This forms a small right angle triangle here, and solve it using what, Pythagoras theorem. That is hypotenuse. This is the hypotenuse. Hypotenuse square equals to what? This is the opposite square plus what? Adjacent square. In this case, the smaller radius, which is 6 centimeter, forms what? Adjacent, which is what? 6. And the height here, which we have calculated, gives what? 4.5, forms what? Opposite. So we can use Pythagoras theorem to solve what? For the slant height here. So we do that here. That is, so the height of the whole cone becomes what? 10.5. To find the slight height of the whole cone, we consider the triangle and solve using what? Pythagoras theorem. That is L of the whole cone, which represents as what? L equals to what? Opposite, which is what? 10.5 square plus 14 square. That is hypotenuse square equals to what? Opposite square plus what? Adjacent square, the Pythagoras theorem. So go back to it. So we have what? Square root of what? 10.5 square plus 14 square. If we solve all through together, you make L the subject of a formula, you will get 17.5 as the what? Slant height of the what? Of the whole cone. You will get 17.5 as the what? Slant height of the whole cone. I recap, using Pythagoras theorem. Using what? Pythagoras theorem, that is the slant height, the capital letter L, it will give you what? Opposite square plus what? Adjacent square. And the opposite square is what? 10.5, and adjacent square is what? 14 centimeter. So if you insert it in the formula of what? Pythagoras theorem, you will get your L to be what? 17.5. Same applies to the what? To the smaller cone. Since we have the height to be what? 4.5 and the radius to be 6, we can use Pythagoras theorem also to what? Calculate the what? The smaller slant height. To calculate the what? The smaller slant height, which will give us what? Small letter L square equals to what? Opposite square, which is 4.5 square, over plus adjacent square, which is what? 6 square. And solving through, you have your small letter L to be what? 7.5 centimeter. So mathematically, and if you have the whole height to be what? 17.5, and the smaller height, this height from this distance to this distance will be what? 10.5. Obviously, this place will be what? 17.5 minus what? 7.5, which is going to give us what? 10 centimeter. That is the slant height of the what? Of the frustum is what? 10 centimeter. You can see. Therefore, the slant height of the frustum becomes the height, the slant height of the total cone minus the slant height of the what? Smaller cone will give us what? The slant height of the frustum. The slant height of the frustum. So by that, we know that our curved surface area is what? Pi L equals to open by capital letter R plus small letter r. And we have calculated our our L here to be what? 10 centimeter. And from the question, we are given that R to be what? Capital letter R to be what? 14 centimeter, and small letter r to be what? 6 centimeter. Pi is given as what? 3.142, or you can use 22.22 over 7 as a fraction. But in decimal is what? 3.142. If you calculate it through, that is 3.142 times 10, which is L, plus R plus capital letter R plus small letter r is what? 14 plus 6, which will give you 20. You have your what? Curved surface area to be what? 628.6 centimeter square. The curved surface area will be what? 628 6.6 centimeters square. I would like you to take the question and go through it again and solve by yourself. Please, for you to have the better knowledge of it, you have to solve by yourself. So now, we calculate the total surface area. If you want to calculate the total surface area, I've said earlier that it is what? The sum of the curved surface area plus the area of the what? Top and the what? Area of the what? Base or bottom. This is the what? In this case, this is what? This is the top and this is the what? This is the bottom. The area of this bottom circle and the area of the what? Top circle will give you what? Plus the curved surface area will give you what? The total surface area of the what? Of the frustum. So this is the question. So the area of this place, which is given as a circle, is what? Pi r square. And take note, the r is what? The small letter r, which is given as what? 6 centimeter. And the area of this circle is what? Pi capital letter r square. And the radius here is what? 14 centimeter. Added to the what? To the curved surface area, which we have calculated to be what? 628.6 centimeter square, rather. 628.6 centimeter square. So insert into it. If you have your calculate your pi small letter r square, I would like you to calculate that. Insert 6 squared times 3.142, you get what? 113.14. Insert 14 squared times what? 3.142, you get 616. Adding together, you have what? 1357.74 centimeters square. So this is how to calculate the curved surface area and total surface area of a what? Of the frustum of a cone. You can also calculate the what? The volume using the formula provided. So next we go to the frustum of a pyramid. The frustum of a pyramid is the same thing. When we say frustum, we already know the meaning as what? It is a portion cut off, but in a parallel form to give you a what? The same base, the same top and what? Base. Look at it. They are cut parallel, whereby what? The top and the base forms the what? The same side. They form the what? The same side. So in this case, it is we all know that frustum is what? Is the cut off part, and the smaller part cut above is gives what? A smaller frustum also. As said in the cone, when you cut a whole cone into two, it's giving you a smaller cone and what? A frustum. Also, when you cut a pyramid into two, it's giving you a smaller pyramid and what? A frustum of the what? The pyramid. So this is called the what? The frustum of the pyramid. So let's go. The volume of the frustum of a pyramid. The volume of what? Frustum of a pyramid. Recall that when we treated in our last class the volume of the pyramid, I told you the volume of the pyramid is given as 1/3 times base area times height. 1/3 times base area times what? Height. In the case why we are using base area, because a pyramid can have what? A square base or a rectangular base. In the last class, what we did was what? A rectangular base pyramid. And you know the area of a rectangle is what? Length times breadth. So in the case we can have what? A square base pyramid. We can have a rectangular base pyramid. But it doesn't break any of the rule, because the volume equals to what? 1/3 times what? Base area, the area of the base, times what? The height. So we all obviously we know that this will be the what? The height. From the vertex here down is what? Height. And from here, this is the height of the frustum. From here down here forms the what? Height of the frustum. And from here down here forms the what? Height of the smaller pyramid produced what? After cutting parallel. So let's go. So to calculate the volume of a pyramid, to calculate the volume of the frustum of a pyramid, it is as easy as that of the cone. That is, you have to calculate the volume of the whole pyramid and subtract the volume of the smaller pyramid cut off, and it will give you what? The volume of the what? The frustum. You calculate the what? The subtract the what? Volume of the smaller pyramid, which is 1/3 times base area times height, from the what? The larger pyramid, which is what? Also 1/3 times base area times height. So here we represent our height here of the whole pyramid as what? Capital letter H to indicate the height of the whole pyramid, and small letter h to indicate the what? The smaller height of the what? Smaller pyramid. And if you subtract them together, you give you what? 1/3 times base area times h, capital letter H, minus 1/3 times base area times small letter h. Alternatively, in case you don't want to go far and you are not, you have given the height of the frustum, or already you have given the height of the frustum. If you solve all through, break this through using similar triangles, you have V equals to what? 1/3 times h. In this case, this h is the what? Height of the frustum. I told you before, if this is a frustum, from the point here down here, it has what? Its own height. So that small letter h is what? The height of the what? Frustum. And what? In this case, B1, open bracket, B1 plus B2 plus square root B1, B2, where B1 is the base area of the what? Of the top, and B2 is the base area of the bottom. This is the same formula as this, base area of the bottom, plus what? Square product of what? Base area of the top times what? The base area of the bottom. So this is the alternative method in solving. You can use both formulas, how conducive it is for you to use. So you can use V equals to 1/3 times base area times height of the whole pyramid minus 1/3 times base area of the smaller pyramid times height of the smaller pyramid. Or you can use V equals to what? 1/3 times H, open bracket, B1 plus B2 plus square root of what? B1, B2. Where H here is the height of the what? Frustum. B1 is the base area of the top. B2 is the base area of the bottom plus what? Square root of the product of the what? Of the both base area of the what? Top and bottom. I'd like to take one example with you. And it goes thus. Example. A frustum. This is a frustum. This is a frustum. We already know this is, if you add them together, is a whole pyramid. But this, if you cut them parallel to give you cut them parallel to the base of the what? Whole frustum to give you a what? A smaller pyramid and a what? A frustum. When a whole pyramid is cut into two, it's called this what? A smaller pyramid and a what? A frustum. So it gives out a frustum of a pyramid is 3 centimeters square. You know, I told you earlier that a pyramid can have a base which is what? Rectangular or square. But in this question now, it is a what? A square. And you know the length, the base area, the area of a square is what? Length times length. Unlike that of a what? Of a rectangle, which is what? Length times breadth. So a frustum of a pyramid is 3 centimeters square at the top. A frustum of a pyramid is 3 centimeters square, 3 centimeters square at the top. That is the base area here is what? 3 centimeters. And 6 centimeters square at the bottom. That is here is what? 6 centimeters square. And the height is what? 5 centimeters. That is the height of this frustum, not the height of the whole pyramid. The height of this frustum is what? 5 centimeters. Calculate the volume of the frustum. Calculate the volume of the frustum. 2 ways to solve it. We can either calculate what? The volume of the whole pyramid and find the volume of the what? Smaller pyramid, then subtract to give us what? Volume of the frustum. Or we indicate the what? The formula, which is what? A equals to 1/3 times what? H, which is the height of the pyramid of the frustum, given here, open bracket, B1 times what? B2 plus square root of what? B1, B2. And you know the base area of the top here is what? 3, which is what? 3 square. And base area of the bottom is what? 6 square. And the height is what? 5 centimeters. 5 centimeters. So we go to the solution. So this is the solution. We will be using this formula, the second formula, which is what? Volume of the frustum is what? V equals to 1/3 times H, open bracket, B1 plus B2 plus square root of what? B1, B2. I told you B1 is the base area of the top, while B2 is the what? Base area of the bottom, and H here is the what? Height of the frustum. The height is given as what? 5 centimeters, and the base area is what? 3. Base area of the top is 3, which where if you find the base area, which is what? 3 times 3, which will give you what? 9 centimeters square. While the what? Base, the bottom is given as what? 9 is given as what? 6, which is what? 6 times 6, which will give you what? 36 centimeters square. And the square root of the product of the bases will give you what? 18. That is 9 times 36. The square root will give you what? 18. So applying the what? The formula, V equals to 1/3 times H. H here is what? 5 times 9. B1 equals to what? 9 plus what? B2 is 36 plus what? 18 will give you what? 105 centimeter cube. 105 centimeter cube. So by now, I believe we all know what a frustum is. It is a cut out region. The remainder, if you cut a cone into two, it will give you a smaller cone, and the remainder, which doesn't form a cone, is what? The frustum. Likewise, if you divide a pyramid, cut them parallel to in line with the base, horizontal in line with the base, to give you what? A smaller pyramid, and produce a what? A frustum. So we said how to calculate the curved surface area of the frustum, that is the curved surface area of the old cone minus the curved surface area of the what? Smaller cone cut out. So we give you what? The curved surface area, while the total surface area of the frustum of the cone is given as what? The curved surface area of the cone plus the what? Area of the top and area of the bottom. While the volume of the pyramid, when we came to pyramid, gives us what? B equals to what? 1/3 times H, open bracket, B1 plus B2 plus square root of B1, B2. We have come to the end of the class now. I have sent our questions ahead in your lesson notes, and with this explanation, I believe you can solve more and more questions using all these formulas provided. Using all these formulas provided. Even aside from the question, you can go into your textbook and try more questions. Thank you very much for your time. I will see you in the next class. Thank you.